I'm sure you would remember all the basic facts about the sine ratio. So let's quickly now check out a video and understand how does the sine function behave and how do we plot the graph of the sine function. We have already learned that if this is a unit circle with a point P on it, then sine theta is nothing but the y coordinate of point P, isn't it? So using this, if I plot all the different values of theta along the x-axis and the corresponding values of sine theta along the y-axis, can you tell me what will be sine 0? That means I'm trying to say if theta is 0, what will be sine theta? Well, that's obvious. If theta is 0, y coordinate of point P will be 0 and hence sine theta will be 0. Do you get that? That's simple. Now, if theta starts increasing in the first quadrant, then what happens? Well, if theta starts increasing, can you see sine theta also correspondingly increased? Well, let's see that again. Okay, so as theta was increasing in the first quadrant, my sine theta was also correspondingly increasing. But when theta becomes pi by 2, sine theta became 1. Yes, that's what happened. Okay, let's continue. Now, I'm allowing my theta to vary in the second quadrant. Let's see what happens then. When theta varies in the second quadrant, oh my God, what can you see? The values of sine theta are decreasing correspondingly. Did you see that? Okay, let's watch that out again. As my theta is varying in the second quadrant, what is happening to the values of sine theta? They are correspondingly decreasing. And when theta became pi, sine theta again became 0. So what did we understand? In the first quadrant, when theta is 0, the y coordinate of this point P is 0 and hence sine theta is 0. That gives me 0, 0 as a point which lies on the graph of the sine function. Cool. Now, if I take theta to be anything greater than 0 but yet less than 90, correspondingly the y coordinate of the point P will be greater than 0 but less than 1. Yes? So say this is somewhere my theta. So sine theta is coming out to be strictly between 0 and 1. Now let me increase my theta but yet remain in the first quadrant. Okay? Correspondingly, the y coordinate of this point P will be increasing, but it will still be less than 1. So say this is my new theta. In that case, this is sine theta. And finally, when theta is pi by 2, the y coordinate of this point P is equal to 1. So sine 90 or sine pi by 2 comes out to be equal to 1. That means corresponding to the interval 0 to pi by 2, the graph of the sine function comes out to be this. Understood? Now let's continue varying our theta and now move in the second quadrant. Okay? I know at theta equals pi by 2, my sine theta is 1. That's not a problem. We understood that. Now, if I take theta to be anywhere in the second quadrant, okay? Cool. Correspondingly, you can see the y coordinate of this point P will be less than 1 now, but of course greater than 0. So say this is somewhere my theta between pi by 2 and pi. So correspondingly, the value of sine theta is coming out to be anywhere between 0 and 1. It's definitely less than 1 but greater than 0. Now let me increase this theta. Fine, not a problem. Let me take a bigger theta. Okay. So correspondingly, what will happen to the y coordinate of the point P? It will yet decrease, but still it will be positive. Okay, so let's say this is my new theta between pi by 2 and pi. So sine theta is coming out to be yet smaller, but still between 0 and 1. And finally, when theta reaches pi, the y coordinate of point P becomes 0. So sine pi comes out to be 0. And hence you get pi comma 0 as a point lying on the graph. That means corresponding to the interval pi by 2 to pi, the graph of your sine function comes out to be something like this. Yes, do you agree? So this justifies that in the first quadrant and the second quadrant, this is the graph of the sine function from 0 to pi. Now let's explore what happens in the third and the fourth quadrant. As we move in the third quadrant, let's observe the values of the sine theta become negative. Can you see that? Yes. As I move my theta in the third quadrant, correspondingly sine theta values become negative. And when theta reaches 3 pi by 2, sine theta is equal to -1. Yes. Now, let's move on to the fourth quadrant. Cool. When I move in the fourth quadrant, what is happening to the values of the sine theta? Can you see that? Well, what happened? As I moved in the fourth quadrant, correspondingly what happened? The values of the sine theta are becoming lesser and lesser negative, and when one complete revolution is done, that is when theta is equal to 2 pi, sine theta is coming out to be again 0. Okay, so what did we observe? That when theta was varying in the third quadrant, sine theta became negative and reaches its minimum equal to -1 at theta equals 3 pi by 2. And when I move beyond 3 pi by 2 up till 2 pi, sine theta values are correspondingly become lesser and lesser negative, and at theta equals 2 pi, sine theta is again 0. Yes, isn't that amazing? Well, let's understand it in a better fashion. When my theta was pi, then the y coordinate of point P is 0. So sine pi was 0. Cool. If I take the value of theta in the third quadrant, what happens to the y coordinate of point P? Can you see the y coordinate of point P will now be lying along the negative y-axis. The y-coordinate of point P will now be measured along the negative y-axis. So obviously, the y-coordinate of point P will be a negative number between -1 and 0. That's obvious. Yes. So if I take this theta between pi and 3 pi by 2, I am getting sine theta to be anywhere between -1 and 0. Okay, let's take another value of theta, not a problem. Again in the third quadrant. Yet bigger I am taking, okay? Yet bigger value. This is my theta, this is my P. So what happens to the y-coordinate of point P? Again, it's negative. But it's more negative now. Isn't it? It's again between -1 and 0, but now it's more negative. That means if this is my new theta, then somewhere here will be sine theta. And ultimately, when this theta reaches 3 pi by 2, the y-coordinate of point P happens to be equal to -1. And hence sine 3 pi by 2 comes out to be -1. So now I can say that corresponding to the interval pi to 3 pi by 2, the graph of the sine function is this. Yes. Now, let's move on to the fourth quadrant, cool? Okay. If I move on to the fourth quadrant, I know at 3 pi by 2, my sine theta is -1. If I take any theta in the fourth quadrant, what happens to the corresponding value of the y-coordinate of point P? Can you see? Yet the y-coordinate of point P is yet negative. It is between -1 and 0, but it is greater than -1. Okay? It is still between -1 and 0, but it is greater than -1. That means corresponding to this theta that I have just taken between 3 pi by 2 and 2 pi in the fourth quadrant, I am getting the corresponding value of sine theta to be greater than -1. Cool? Yes. Now let me take another theta. Okay, yet bigger than this. Cool. So let's say this is my theta in the fourth quadrant itself. So now what happens to the y-coordinate of point P? It is yet bigger than -1. Okay, so if now this is my new theta, yet bigger than -1, so it will be yet above this point. And finally, when I reach theta equals 2 pi, then in that case, my point becomes 1, 0. So y coordinate of point P is 0. That means at 2 pi, sine 2 pi is 0. So this gives me the idea of the graph in the interval 3 pi by 2 to 2 pi. What do we get? That in this interval, the graph of the sine function will be this. So I get that corresponding to the third and the fourth quadrant, this is the graph of the sine function. So what did you see? From 0 to 2 pi, that is, in one complete revolution, we have been able to analyze the graph of the sine function. We know the maximum value till now that it has obtained is 1, and the minimum value till now that it has obtained is -1. We can also say that at 0, it is 0, at pi by 2, it is 1, at pi, it is 0, at 3 pi by 2, it is -1, and at 2 pi, it is again 0. So that completes our discussion about the behavior of the sine function in one complete revolution. That means when theta varies from 0 to 2 pi. We've understood that at 0, sine theta is 0. As theta varies in the first quadrant from 0 to pi by 2, sine theta increases from 0 to 1. At pi by 2, sine theta obtains its maximum value equal to 1. Now, when theta moves in the second quadrant, that means when theta varies from pi by 2 to pi, sine theta gradually starts decreasing, and at theta equals pi, it becomes equal to 0 again. Then, when theta varies in the third quadrant from pi to 3 pi by 2, sine theta becomes negative. And at 3 pi by 2, sine theta is -1, which is its minimum value obtained. Further, when theta moves in the fourth quadrant, sine theta starts becoming lesser and lesser negative, and at theta equals 2 pi, that is when the revolution is completed, sine theta becomes 0 again. Yes, this completes my discussion about the graph of the sine function for the first revolution 0 to 2 pi.